So hello everyone, today we'll be solving this Hackerrank dynamic programming problem which says we define subsequence as, okay, so we know what's a subsequence. So given an array, find the maximum possible sum among all non-empty subarrays, all non-empty subsequences, okay. So this is for subarray, this is for subsequence. You need to find the maximum, which is pretty easy. I would write my C++ boilerplate. Alright. Now what's the input format? You'll be given some test cases, right? So let's take those test cases. Then you will be given size of array, I guess. Yeah. Let's take everything long now. And we'll write our main logic in a function called solve. No, wait, why to write it in solve? Let's write it here itself. So we know how to find maximum subarray sum using Kadane's algorithm, I hope. If you don't know, I would really love to explain it to you. Kadane's algorithm. So there's a standard algorithm which is very efficient for finding maximum subarray sum. It's very simple. You take something called as a current sum, which you initialize it to 0. Currently, you don't have anything to hold, any sum to hold. Then you have something called as a max sum, which is minus infinity. How would you write minus infinity? Okay, let's take these ones also as long. Let's take CORR as 0 and long. Let's keep it as answer. Let's keep it as answer and it should be minus infinity. Since we don't have anything as such minus infinity, we'll take it as int min for now. Okay, all right. Now let's iterate through the array. Let's iterate through the array, and if let's add current plus equal to a, add every array element to current. So essentially, if it's a negative element, the sum would decrease. So when the sum becomes totally negative, if the sum becomes totally negative, in that case, reset the current back to 0 so that you calculate the sum for the next subarray, leaving that negative subarray, leaving the thing that gave you a negative answer. Then if, or else I should say else if, I can directly write max function, right? Answer equal to max of answer comma current sum. At the end, answer would always store the max value, so you would store the answer for now. Since you're writing this in main function, I'm not doing return answer. Till here, Kaden's algorithm is over. That means we are done with finding maximum subarray sum. Now comes maximum subsequent sum, which is even more easier. You take a result, just add the positive values. Negative values will decrease the sum, so add only the positive values. If your current array element is greater than 0, that means it's positive. Then please add it to your result. By the end of this loop, result would be storing the maximum subsequent sum. So also you need to check for something else. What is it? If the whole array is negative, result shouldn't have something as such. It shouldn't have 0. Like you don't have 0 in the array, right? So the result also shouldn't have 0. You should always include the max element. So I would say, how to find if a whole array is negative? It's simply, I would write if max element. I hope you know this function max element of arr.begin. If max element of arr.begin, arr.end, if max element itself is less than 0, if max element itself is less than 0, that means whole array is negative. In that case, uh, my, let's keep this if statement here. Okay, in that case, my result would be equal to the max element itself. So let's copy this, paste it here, keep a semicolon, and we are good to go. Cout answer space result and L. This should absolutely work. So before that, also the cadence algorithm part I would like to modify. If see my current sum equal to 0, that means it would never go more than, like, even if the max element is negative, in this case it would still output 0, and 0 is not present in the array, it would still output 0. So that's a problem, right? Instead we would like to modify it. So current would be equal to max of current comma current, sorry, arr, I mean a comma current plus a. I guess I need to typecast this to long. Fine. And this shouldn't be initialized to 0. I would like to initialize it to array of 0 instead. So let's try running this code. One test case failed. Why is it so? Okay, so we are already initializing it with array of 0, and we are also iterating array of 0, so extra 1 is getting added. That array of 0 is getting added twice. So let's modify this for loop. Int I equal to 1, I less than arr dot size I plus plus, and this should be arr of I instead. Here also it should be arr of I. Here also it should be, that's it, nothing to change, nothing else to change. Once again, let's run this. Hopefully, yeah, both test cases got passed. Now let's submit this, and one test case failed. One test case failed. Let's see what's the error, what could we possibly optimize. So I have found one potential issue that could cause this. See, what we are doing wrong. You are initializing current to array of 0 and answer to int1, which is fine. But, wait, yeah. But what's the issue is, you're starting this loop from array of 1, right? You're starting from the first index. So the problem comes when array has only one element. That means array of 0 is only defined. Array of 1 is not defined. This loop won't be executed since I less than array of size fails, condition fails. So loop won't be executed. Now answer would never be updated. So now what you will be doing is just keep this as array of 0 2. Now it should be more sensible and should work. So all the test cases passed. Yeah, all the test cases passed. So that's it for today. Stay tuned for next video. Thank you.